हेलो दोस्तों, कैसे हो। मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं।
So when I say design of Cotter joint, what it means to find dimensions of various parts of Cotter joint. What do you mean by design of Cotter joint? We will find the dimensions of various parts of the Cotter joint. So what are the various parts of the Cotter joint? I will tell you what is Cotter joint. Before that, we will understand what are the various parts. The parts are socket. Second part is spigot, and third part is Cotter. This spigot, this part, it looks something like this. See, this is spigot. So it is similar to what I have drawn. Now there are various parts in this spigot. The parts are like this. This is a rod. This one is rod. Where is the rod? Here. This one. This one is rod. Then this part. This one. Okay. This is called as spigot. And there is this part which is called as spigot collar. Spigot collar. Which is this? This is the spigot collar. So all of you have seen this spigot now, so you can imagine how a spigot looks like. Okay? Any doubt to anyone? किसी ने देखा नहीं spigot कैसे दिखता है? There is something in this hole. I will talk on this afterwards. Okay? Right now you understand that this is a spigot. Now another part. Which is another part? A socket will look something like this. So what are the various parts here? Again, this particular part is called as socket. I will show it to you in a moment. This is called as rod, and this thing is called as socket collar. Socket collar. It looks like this. So you can see this is a rod. This part is a rod. This part is a socket. This is a socket, and this part is socket collar. Now you can understand from the sketch that this is a hollow part. This is a hollow part. Can you see this is a hollow part? Whereas this spigot is a solid part. Spigot is solid. Spigot is solid, socket is hollow. Now, since spigot is solid, socket is hollow, we can insert the spigot into socket. Insert the spigot into socket. And these are the two rods now. This is one rod, this is another rod. So you can see how the assembly looks like this. Rod, spigot, inside the spigot there is socket, then these are the two collars, and this is another rod. And this is used to this rod and this rod, this rod and this rod. Both the rods are pulled. Rods are pulled. So if I pull both these rods, this will come out. This will come out. If I pull this rod, this will come out. And we are talking about Cotter joint. So if it comes out, then it will not be a joint. So we want a joint. So this is a temporary joint. This is a temporary joint. So in order to make it a joint, what will we do? We'll add one more part in this. We'll add a part, this part. This is called as cotter. Cotter. How the cotter looks like? The cotter looks like this. This is front view. This is top view. and this is side view of a Cotter. Is this clear to you? Cotter is inserted in it like this. Now this has become a joint. Now when I apply force from this end of the rod as well as from this end of the rod, this will not move. This will not move. I can apply force and this will not move. So this has become a socket and spigot Cotter joint. So I explained you the three parts of socket and spigot Cotter joint. For one part is one part is Cotter like this. Second part is spigot like this, and third part is socket like this. Now since we have to insert Cotter in it, what we have to do, we have to create a hole in this like this. So you can see here, I will create a hole in this, something like this, and here also I will create a hole something like this. Okay, that's why you can see there is a hole in this, so that I can insert the Cotter. Is this much clear to all of you? Any doubt to any student?
No, sir.
So all of you have understood that there are three parts in this socket and spigot Cotter joint. What are the three parts? The first part is socket, second part is spigot, and third part is Cotter. So socket comes with its collar. So socket comes with its collar. Spigot also comes with its collar. Now how this is manufactured? Okay, first we'll see how this is manufactured. So this is manufactured by the process of forging. All of you have studied forging in previous semester. Forging, it is a process in which a part is heated and then it is hammered to give the required shape. It means that if this is a rod, then it is heated, then it is hammered by a hammer like this, and then it is made in the shape of socket and spigot. It is made in the shape of socket and spigot. So how is this made? This is made by the process of forging. It means that this socket collar, the body of the socket and the rod, it's one unit. It is one unit. It is not that this collar is joined to this spigot, or it is bolted, it is riveted, nothing like that. It is the same part. This rod, this and this, it's one unit, it is one part, and a hole is created in this. Same is with the Cotter. Same is with the socket. This rod, this rod, this socket, and this socket collar is one unit. It is one unit. Now, after understanding this, now I will tell you what is a socket and spigot Cotter joint. So, socket and spigot Cotter joint is a temporary joint. It is a temporary joint. Why it is called as temporary joint? Because you can remove the Cotter. You can insert the Cotter. Okay, if you remove or insert the Cotter, it becomes free. Okay, there is no connection between the socket and spigot, so it is a temporary joint. It is subjected to axial load. Axial load. What do you mean by axial load? Axial load means the load passes through the axis. So if I draw the front view of this, then the front view will be like this. See, this is the socket. Okay, in this socket there will be a hole, and in that what will be inserted? Spigot will be inserted like this. The spigot will be inserted, and then this is the spigot collar, and spigot comes with its own rod, and this is called as the axis, imaginary line. This is axis, imaginary axis, or imaginary line. So the load is applied like this. Load is applied like this. Now this load, it can be So it is axial load. It is axial load. But this axial load can be either tensile or it can be compressive. It also means that it is a reversible load. Reversible load which changes its, yes, it changes the direction. So this load sometimes which is tensile can become compressive like this. So this is the joint which is used to connect two rods. It is a joint which is used to connect two rods. This is rod number 1 and this is rod number 2. Now understand the difference here between rod and shaft. And I will add one more thing, bar to it. Rod, bar, shaft. Shaft is always subjected to rotation. So it will be subjected to torsion. So in most of the cases, whenever I say shaft, shaft is a rotating machine element. It is a rotating machine element. Bar and rod are not rotating machine element. When I say rod, it is not going to rotate. It may or may not rotate, but shaft, when I say shaft, it will always rotate. So I have not used the word shaft here. I have used the word rod. Can anyone tell me the difference between rod and bar? Rod means it is always circular in cross section, whereas bar can be square, okay, something like this, or any cross section. Rod and bar. We have studied as in strength of material. So here we are interested in quarter joint. We are interested in rod. Okay, इसका मतलब ये क्रॉस सेक्शंस कुछ नहीं रहेगा, ये हमेशा सर्कुलर ही रहेगा, हमेशा सर्कुलर ही रहेगा. So you got an idea now what is a quarter joint? It is a joint which is used to connect two rods, and these rods are subject to axial force. The force may be pull type or push type, that is tensile or compressive. And in order to make it as a joint, we use a quarter. And since we are using a quarter, the joint is a temporary joint. It's not a permanent joint. Till here, is it clear?
Yes, sir.
Now, before I tell you the applications, let me tell you how a quarter looks. Now, I have already shown you how a quarter looks. A quarter is something like this. Okay, it is a rectangular piece. Now, if I draw the front view of this, front view will be something like this. But imagine that this is a rectangular piece, and how it is inserted, it is hammered. It is hammered into a slot, into the slot which is created in the socket and spigot. Now, if it is hammered, what will happen? Will it go inside the slot? If there is enough clearance, then it will go. If there is less clearance, it may not go. And once if it fits, and understand that it is not made of wood, it is not made of wood, it is made up of mild steel. So once you hammer it and insert it, it may not come out. For that purpose, what is done? Taper is provided on this quarter. This quarter is not designed, it is not made like this. It is having taper something like this. So you can see there is a taper provided here. Taper provided here. So that what happens when you hammer it inside, it will go and fit. And when you have to remove it, you will hammer it from the other end, and it can come out. And when it is in use, that time it remains fit. It keeps the joint fit. That's why taper is provided. Now this is important here to understand this taper and how the taper is provided. The value of taper is 1 in 48, 1 in 24, or 1 in 12. Now understand the meaning of this. This means that for a length of 48 mm, taper is 1 mm. Similarly, for a length of 24 mm, taper is 1 mm. And similarly, for a length of 12 mm, taper is 1 mm. So how to show it here? Can you see the taper? Yeah, I will exaggerate the value of taper here so that it can be clearly seen by all of you. थोड़ा ज़्यादा टेपर दे देता हूँ, मतलब इजीली दिखेगा सबको. ये बहुत ज़्यादा टेपर दे दिया मैंने. I have exaggerated it. Now see, suppose this length is 96 mm. 96 mm. What I am saying? I am saying that the taper is 1 in 48. Matlab for a length of 48 mm, the taper is 1 mm. So for a length of 96 mm, taper should be 2 mm. Taper should be 2 mm means this distance should be 2 mm. See, is there any taper in this? There is no taper. No taper means this is how much? For example, 10. So this will also be equal to 10. So I will say there is no taper. Now if I am saying there is a taper of 2 mm, it means that there should be difference in this top dimension, and this bottom dimension, and that difference is 2 mm. So this means that taper is 2 mm for a length of 96 mm. So for a length of 48 mm, the taper will be 1 mm. This 2 mm is looking too big, but I have deliberately drawn it so that you will understand. Now, if this dimension is say 10 mm, then this will be how much? This will be 11 mm, and this will be 9 mm. So what is the taper now? 11 minus 9 is 10. Sorry, 11 minus 9 is 2, and at the center it will be average of this 11 plus 9, that is 20. 20 divided by 2 is 10. Yeah, now this taper, this particular taper is on one side only. Okay, sometimes, now this is on one side only. ये जो दिख रहा है 1 in 48, this is on one side only. If the taper is on both the sides, say like this, then we will see it is both side tapered. Here it is 1 in 48, here it is 1 in 48. So बीच का जो डायमेंशन है, ये अलग टेपर हो गया, ये अलग टेपर हो गया. As I explained you for this side, the similar case is for this side. Okay. So generally taper is provided on one side only, it's not provided on both sides. And the purpose of taper I have told you, so that we can insert the cotter and we can remove it afterwards. It's a temporary joint, it's not a permanent joint. That's why taper is provided on one side only. And if what will happen if taper is provided on both the sides? If taper is provided on both the sides, then it will come out easily. Okay, in operation it may come out easily because taper is provided on both the ends. So generally taper is provided on one side only, and this is the normal value of taper that is used, that is 1 in 48. If this value is used 1 in 12, if this value is used, then what you have to do, you have to provide screws here. You have to provide screw so that the cotter should not come out of the slot. Screw is to be provided. Okay, this you can see this is a corner, but actually this should not be a corner. This should be a rounded surface like this. Okay, it should be a rounded surface. Now here also it will not be a corner, it will be a rounded surface. It solves two purposes. The first purpose is it will not harm the operator who is using it. It will not harm the operator, and second is it will reduce the stress concentration. Okay, there will be less stress concentration if it is like that. So already I have told you slightly about what is stress concentration in earlier lecture. We will talk more on this stress concentration in the fourth module. But the basic purpose that you can understand here is, if you are not able to understand about stress concentration, you can understand that it may harm the operator. So to prevent that, it is made tapered like this. It is made curved like this. This is made up of mild steel and it is wedge shape. Since it is taper, it is having taper on this side, so it can be called that it is wedge shape, and it is having this taper 1 in 48, 1 in 24, or 1 in 12. So is this cotter clear to all of you? Cotter part?
Yes, sir.
Is having these applications to connect the piston rod to the crosshead of reciprocating steam engine. It can be used to connect piston rod and pump rod. It can be used to connect wall rod and its stem, and it is also used as a cotter foundation bolt. These are the applications. These are the applications of cotter joint. Okay, now we'll see how to design a cotter joint. So you have understood now what exactly a cotter joint is, how it is used, what are the applications, what are the various parts. Now we'll design this, and you have also understood the concept of this factor of safety, this thing, this concept of factor of safety, and what has to be done so that the part does not fail, and induced stress, this one, this also you have understood. Okay, now we'll see how to design this part.